Are you curious about how modern electronics perform complex tasks so quickly? How your smartphone instantly processes your photos, or how a robot can make decisions in just a fraction of a second? The secret often lies in something you might not have heard much about, a powerful technology called FPGA. Welcome to the Beginner's Guide to FPGA. In this video, we're going to explore what an FPGA is, why it's such a game changer in the world of technology, and how you can start working with it even if you're completely new to electronics. Today, we're diving into the fascinating world of customizable chips, tiny yet mighty devices that don't just run software. They become the hardware you design. Unlike traditional processors, which have a fixed way of operating, FPGAs are like a blank canvas. You decide how they work. You can reprogram them anytime, turning the same chip into a new device over and over again. From space missions to medical devices, from video games to artificial intelligence, FPGAs power some of the coolest and most advanced tech around. And the best part? It's a skill you can start learning today, step by step. So if you're ready to unlock your creativity and take your first step into the future of technology, let's get started. Let's solve the mystery. What is an FPGA? Have you ever wished you could build your own computer chip, one that does exactly what you want it to do? Well, that's what an FPGA makes possible. FPGA stands for Field-Programmable Gate Array. Let's break it down. Field-programmable means you can program the chip after it leaves the factory, right from your desk. And gate array? That's the thousands of tiny logic gates packed inside the chip. You decide how these gates connect and behave, turning them into whatever digital circuit you need. Think of an FPGA like a giant Lego kit for electronics. Each logic block is like a Lego brick. You piece them together to build anything, from something as simple as a blinking LED to something as advanced as a custom CPU. And here's the best part. If you change your mind or make a mistake, no problem. You can reprogram the entire chip again and again. It's flexible, powerful, and limited only by your imagination.
So, what makes an FPGA different from a regular processor? Let me make it crystal clear for you. A regular processor, like the one in your laptop or smartphone, follows a set of instructions, one at a time, step by step. It's a bit like a chef carefully following a detailed recipe. The chef reads an instruction, grabs an ingredient, stirs the pot, waits for the timer, and moves through each step in order. This kind of system is flexible and works well for general tasks. But there's a catch. The chef can only do one thing at a time. Even if the recipe is perfect, there's still a bottleneck. Complex or time-sensitive tasks can slow things down. Now imagine a totally different kitchen, where instead of one chef, you have a team. Each chef handles a different task at the exact same time. One chops vegetables, another stirs the sauce. One is baking, another is plating. Everything happens in parallel, fast, and efficient. That's what it's like to use an FPGA. An FPGA doesn't follow instructions. It becomes the machine you design. You build the logic directly into the hardware, specifying exactly how it works. And once it's running, everything happens simultaneously, not step by step. This ability to process in true parallel is what makes FPGAs so powerful. They're ideal for high-speed, real-time systems like live video processing, medical imaging, autonomous vehicles, and AI acceleration. So in simple terms, processors are readers. FPGAs are builders. And when you need speed, precision, and custom performance, builders win. Now that we know what an FPGA can do, let's open it up and take a look inside. What's actually going on under the hood of this powerful little chip? At its core, an FPGA is made up of three main building blocks. 1. Logic blocks or logic elements. These are the heart of the FPGA, the tiny programmable circuits that perform logic operations. Think of them as digital mini-machines that can be configured to do things like and, Oregon, not, and more complex combinations of logic. Each logic block typically includes lookup tables LUTs, which store the logic functions, / flip-flops for storing bits of data, like memory, small multiplexers, and carry chains for arithmetic operations. You can program these blocks to act like counters, adders, decision makers, whatever your design needs. Interconnects, or routing fabric. Now, having thousands of logic blocks is great, but they need to talk to each other. That's where the interconnects come in. Imagine a massive network of tiny wires and programmable switches connecting all the blocks. You decide how the wires connect, like drawing your own circuit map. This routing system is what makes the FPGA so flexible. You can literally redesign how the entire chip is wired without touching any hardware. It's like being able to redraw the roads between buildings in a city anytime you want instantly. 3. I/O blocks, input-output. These are the entry and exit points of the FPGA, where signals from the outside world come in and go out. You can connect sensors, displays, memory chips, motors, anything digital to these I/O pins. And just like the internal circuits, you can control how these pins behave. Should they take in a signal or send one out? Should they follow a specific timing protocol? Should they act slowly or at lightning-fast speeds? The I/O blocks are your bridge between the physical and digital world. Modern FPGAs also come with built-in extras, which are specialized blocks, like block RAM, BRAM, which are tiny memory banks for quick data storage. Digital signal processors, DSPs, which are optimized for math-heavy tasks like audio, video, or AI. Clock management units. They are used to control timing and synchronization. Some FPGAs even include hard processor cores. In other words, they include entire CPUs inside them. These extras give you a hybrid environment, part hardware you build, part features ready to use. So, to recap, inside an FPGA, you'll find logic blocks to build your digital functions, interconnects to wire them together, I/O blocks to communicate with the outside world, and powerful extras that take your designs even further. In short, it's not just a chip, it's a blank canvas, a reconfigurable machine, and a hardware playground, all in one. By now, you're probably wondering, okay, FPGAs are flexible and powerful, but what can I actually build with one? The answer? Pretty much anything digital. Let's explore some real-world applications from simple projects to cutting-edge technology. 1. Simple beginner projects. If you're just getting started, you can use an FPGA to build projects like a blinking LED pattern that you can customize and animate, a digital counter that reacts to button presses, traffic light controllers, or basic calculators. These may sound simple, but they teach you how to work with logic, timing, and inputs-outputs, the foundation of digital design. 2. Custom hardware devices. Once you get the hang of it, you can design more advanced devices like audio processors that mix or modify sound in real time, video filters that sharpen images or detect motion, your own CPU or microcontroller designed exactly how you want it to work. Yes, you can literally build your own computer chip from scratch. 3. High-speed systems and industry use. FPGAs really shine in areas where speed and precision are critical. Here are just a few examples. Telecommunications, routing data through high-speed networks, medical devices, real-time heart monitoring or MRI processing, aerospace and defense, guidance systems, radar, encryption, automotive tech, from parking sensors to autonomous driving algorithms, artificial intelligence, acceleration of neural networks for tasks like object detection or speech recognition. In many of these cases, traditional processors just can't keep up, but FPGAs can. 4. Hybrid designs. The best of both worlds. Many engineers now combine FPGAs with embedded processors to create SoCs, Systems on chip. These designs let you run software and custom hardware logic on a single chip, super efficient for robotics, drones, and edge computing. So, what can you build with an FPGA? From blinking LEDs to space-grade systems, the possibilities are endless. You're not just learning how to code, you're learning how to build the machine. What tools do you need to start working with FPGAs? So, you're excited to start your FPGA journey, but what exactly do you need to begin? Let's break it down into a simple toolkit for beginners. 1. An FPGA development board. This is your playground, a physical board with an FPGA chip, input-output pins, and often extra components like LEDs, switches, and USB ports. For beginners, popular choices include Digilent Basis, 3 great for students and hobbyists. Tarasic DE10 Lite, or DE10 Nano, used widely in education and prototyping. Tiny FPGA affordable and great for small projects. These boards come with just enough features to learn, but without overwhelming complexity. 2. A computer and design software. To design circuits for an FPGA, you'll need to use HDL, hardware description language, typically Verilog or VHDL. You'll also need a special design environment called an FPGA IDE. Don't worry, these are often free. Depending on your board, you might use Xilinx Vivado for Xilinx chips like on the Basis 3. Intel Quartus for Intel/Altera-based boards like DE10. Lattice Diamond or IceCube 2 for Lattice chips and smaller FPGAs. These tools let you write HDL code, simulate your designs, and finally, program the FPGA. 3. USB cable and power supply. Most boards use a USB connection to upload your design from your computer to the FPGA. Make sure you've got the right cable and power source usually included in your board kit. 4. Optional simulation tools. Before you burn your design onto the chip, it's a good idea to simulate it. Simulation helps you catch logic errors or timing problems early, just like testing code before running a program. Most FPGA IDEs have built-in simulators, or you can use tools like ModelSim and GTK Wave for waveform viewing. 5. Tutorials and learning resources. The good news? You're not alone. There are tons of free tutorials, forums, and YouTube channels that walk you through everything step by step. Some development boards even come with demo projects and starter code. So, to sum it up, to start working with FPGAs, you'll need a beginner-friendly FPGA board, design software, HDL IDE, a computer, USB cable, and power, optional simulation tools, and a bit of curiosity to explore. You don't need to be a hardware expert, just willing to learn, experiment, and build. And that's the basic flow of how you program an FPGA from code to a working circuit. Of course, each step can take a little time to master, but don't worry, I've got you covered. In my next video, I'll walk you through the entire process step by step, using a real FPGA board from writing your first Verilog code to uploading it and seeing your design come to life. So, if you're ready to actually build something, make sure to check it out and don't forget to subscribe so you don't miss it. Check out my comprehensive guide to FPGA and Verilog to master FPGA in the video description, where you can get free codes to start practicing. Grab your copy today.